twalakonkanya hapo na kulolesha pali operation ya crusher. Number hapa we're going to proceed to look at the operation ya crusher hydroset control. Now ngamulebukisha we explained how the hydroset operated, and one key factor oitwingebukisha kutwafuilishako kushita understand security chakwe bate twalela that hydroset it was more like a bi-directional drive, in the sense that the pump was able to run in one direction if we wanted to, for instance, ukuchita raise hydroset, and then if we wanted to lower the hydroset, it was supposed to run the other direction to allow us to lower the hydroset. Now ngamlefo kuwa in the know of how a hydroset looks like, ngamwadimana fidefi ama cylinder hydraulic jacks ya motoka yakobati, you get to actuate ka lever so that piston center pushes up against the vehicle ngoyo mlefo kwimya. But the whole point is idia exposed end ya piston idia isa mkufuma muri barrel ya jack. That's exactly the way you imagine a hydroset system to operate. Ngate, if you just look at YouTube, then search for hydroset, crusher hydroset operation, and then it will give you a guided illustration. Okay. Then, having said that, ngamasarudesha muri electrical schematic. Muri rang 58. Okay. This rang 58. Maybe let me just zoom in a bit. In the first rung, designation 58, namonat padi HDR. HDR is the resultant, or rather it's dependent on the hydroset pressure switch, which is shown now in the normally open condition. Now, to know how the normal state of HDR, we need to look at how it's been used. So MUSC9 nam 70. So MUSC9 is being used for an indicator lamp, and then MUS70 is being used again with an indicator lamp, or a lamp if you want, which is in parallel with the hydroset low pressure siren. Okay, so if clearly we look at HDR in this path, which is used as a normally closed condition. Okay, so if it's like this, what we just need to know is, okay, in this position it's being shown like it's open, but you can think of it as maybe the auxiliary contact of the main isolator for the crusher. Okay, that auxiliary is the one which carries the path air control or any other safety feature that you would want. So assuming this path is closed up, then the only thing stopping this siren from being actuated or energized permanently is the condition of the hydroset relay auxiliary contact designation HDR closed in this position, normally closed. Okay, so at the point where this is not energized, you have the supply, which is 110 volts, which is the hot end of the rung. It will show up across the lamp, okay, and then also the hydroset low pressure siren, which shows that lamp when this light turns on, then of course it means that the hydroset pressure is low. Okay, because if this was energized, if let's say the hydroset pressure switch was closed, okay, in which case HDR as a relay yalaba energized. Galaba energized, those normally open contacts are going to close, and the normally closed contacts are going to open, which goes to show that in the energized state, this position here will be closed and this lamp will be energized. So that will be the hydroset pressure okay. Okay, so the first one, hydroset pressure okay. The second one, which is controlled through the normally closed auxiliary contact, as hydroset pressure low. Okay, and when the hydroset pressure is low, the hydroset low pressure siren yalambo kudila. And the only way for you to switch off the hydroset low pressure siren is to toggle this switch, okay? Is to toggle this switch in this position, or the one ibale alarm cancel. So that explains how this HDR relay facilitates the control function Moody circuit, okay? And then if we move on to the rung 59, you'd notice that here a thermal overload, designation 4CE3, then followed by 4CD1. So where's 4CD1? 4CD1 is used, or rather is the resultant relay condition in rung 63, okay? I'm calling it a resultant relay condition in the sense that there's overload, then there's 4CE2, okay? Now the overload titu abika pona 4CE3, meaning this position can also be 4CE3, and then 4CE2 ni earth leakage relay. That auxiliary contact of that device is used in this position, normally open, okay? And then going down, you've got a fault reset, and then of course we've got the relay coil itself, 4CD1. So 4CD1 is essentially a fault relay. We can even call it a fault relay pantu. The conditions through which it's energized are essentially fault conditions: thermal overload, earth leakage, control 4CD1, okay? So you consider this as just a fault relay, a fault indication relay, or a healthy status relay, but simply we can just call it a fault relay, okay? Then across it, not quite able at 4CH1, which is a lamp or an indicator lamp. I lamp ngayaka nishimwishi fyati, you are either having a thermal overload condition or an earth fault condition, okay? E4CD1 in this position, this normally open contact, is just an auxiliary contact of this relay 4CD1. So it's just been used to seal in the relay. Once this is energized, 4CD1 relay is energized, it seals in, and the only way to de-energize it, assuming these conditions are normalized, which is to say you've reset the thermal overload or you've reset the earth leakage, upon of course checking what caused those fault conditions in the first place, then you can reset, okay? Only reset once you've rectified the condition of the fault, okay? So that explains this part. Olonga maisa is a foot mudi 59 again. Protection 4CE3 is protection, 4CD1 is protection. So thereafter, not watayama push buttons. So you can either raise the hydroset or you can lower the hydroset. But ayama conditions are whether you are raising or lowering, they are mutually exclusive. You can just have one of these conditions, or rather operations, being performed. If you choose to raise, by you energizing E relay designation 4CC1, normally close contact, auxiliary contact here 4CC1, it used Moody lowering run or network, or if you want, okay? So when this relay coil is energized, it opens this position so that nangumwazati ninkapali lowering, nothing happens on account of this position being open. The same thing goes for the raising. If you pressed the push button to lower, the auxiliary contact of 4CC1, normally closed, is used in the rung for raising, okay? So if you press to lower, the auxiliary contact of the relay 4CC1 is used to open, because we're using a normally closed contact. So energize 4CC2 coil or relay if you want, then its normally closed auxiliary contact is going to open in the rung to raise, and so nangumasati ningapadi raise, nothing will happen. So these two operations are mutually exclusive, okay? So that takes care of that. And then apart from this interlock relationship between the two relays, okay, they are also used to control the the solenoid valve. Okay, they're used to control the solenoid valve. In Moody rang 65, either normally open contact of either the relay, which is responsible for lowering, or the relay which is used for raising. The auxiliary contacts of these two relays are used in a parallel configuration to control a lamp, which is 4CH2. So 4CH2 essentially is just being used to show that hydroset ile sela, irrespective of the direction, whether you are lowering or raising lampu ifuile ukwaka. Okay, and then Moody rang 67 eomuntu kwete solenoid. Okay, this is where we have a solenoid valve. Okay, so a solenoid valve is just being used to, it's just like the designation solenoid valve is essentially just a typical valve which is electrically controlled. Okay, it's just a solenoid valve. Now this solenoid valve is on the discharge end of the hydroset pump. Okay, it's on the discharge end of the hydroset pump. Maybe let me just bring this up. It's here. Okay, well, we have the hydroset. Okay, so hydroset, this is the solenoid valve we're talking about. This solenoid valve. Okay, come on. So we're talking about this solenoid valve right here. Okay, so this is the solenoid valve which is being controlled. If we just press to raise or press to lower, this solenoid valve will be given a command to open. Okay, and then this pump here, okay, is able to do this bidirectional thing. If we're trying to raise, it means the direction of flow will be in this direction. Okay, if we're trying to lower, the direction of flow will be back, or rather it will help to drain to the tank, okay, which is this tank right here. So clearly, AMA AC motors, if you want to reverse the direction of an AC motor, all you need to do is interchange any two of the phases from the original configuration, then it will rotate in the opposite direction. Okay, so that's just what that is. So we're saying at the time that we're raising or lowering, we're not just opening the or rather commanding the solenoid valve to open, but we are also controlling ama power contactors yanga yabiri, if you like, one in the forward direction, then the other one in the reverse direction. That would pretty much look more like, I know it's not a very good drawing, but maybe this can power circuit. I'm thinking this is it. Okay, let me say more overload. This doesn't help us at all. I don't really have that configuration, but anyway, you get the point. To say, if we're trying to change the direction of rotation of an AC motor, if the original sequence was like red, yellow, blue for one power contactor, okay, then for you to rotate the drive or the motor in the opposite direction, we just go like red, blue, yellow. Okay, and then of course the direction of rotation will change. So that's what we're also achieving. Apart from commanding the solenoid valve to open, this one, when these 2 points close, either 4CC1 closes or 4CC2 closes, energize the solenoid valve, it opens. At that point, we are also controlling the hydroset pump to either run in the clockwise direction or run in the anti-clockwise direction. So that's what that command is also being used for. And upon these can also be attributed to that. We can think of them in this position. So you can think of 4CC1 as as opposed to thinking of it, okay, we can think of it as a relay, okay, a relay with auxiliary contacts which later on control the power contactor, or we can just think of these as the coils for the power contactors, the ones which are directly responsible for either raising or lowering the hydroset. Okay, so there are two ways we can look at this. We can think of this circuit purely as control, nothing to do with the power actuation, which is to say that just the control part of it. But we can also simplify our lives to just say, okay, I am a relays. Okay, these we can just flip to just say, okay, these are now just power contactors, in the sense that they are handling now the power to drive the high voltage, okay, the relatively high voltage to drive the hydroset pump. Relatively high in the sense that you control the coils are 110, but the hydroset pump can be maybe 550 or 220, which is what I'm saying, relatively high voltage. Okay, so that's what these are. Okay, so we'll think of these two positions, 4cc1 and 4cc2, as the power contactors for controlling the hydroset, and that these have got auxiliary contacts which are being used to indicate that the hydroset is running by way of rung 65, and also being used to control the operation of the solenoid valve. Okay, so this is what this is. So having explained this, because we're talking about the hydroset, we're going to insert an object which is a function. Okay, and then this one we're going to call this as hydroset control. Okay, and then as always we need to call function 8 in the OB. Okay, so we're going to call this OB1, and then we're going to insert a network. Then we're going to go to where it says function, then look for function 8. You can just save this. Okay, we can also from here access the code, the block, the function that we've just created. So code block open, protection input. So the hydroset is protection, the hydroset pressure switch is a protection input, and then so is the thermal overload, the earth leakage. I think those are the three protection inputs in this particular configuration. So what do we do? We know that the memory bit addresses designation memory bit 20.0 were protection, so we went as far as memory bit 21.4, so we can start from here. Okay, there's no harm, so because these are just protection inputs. Okay, so the first one is hydroset pressure switch. What do? Okay, so hydroset pressure switch, HPSW. Okay, you can call it anything you want, but I'll just call it this. So hydroset. So we've got the hydroset pressure switch as a protection input. Okay, and then the other protection input we have is we have the hydroset thermal overload and the hydroset earth leakage. Okay, so 4CE3. Okay, yeah, so we have 4CE3, and then this of course is hydroset. Let's copy that, hydroset thermal overload. Okay, hydroset thermal overload, like so. That takes care of 4CE3, insert symbol. 4CE3 is taken care of. Then there's 4CE2, which is a hydroset earth leakage protection. Okay, 4CE2, then the hydroset earth leakage. Okay, Hydroset earth leakage protection, which takes care of 4CE2. And then what we have, okay, this is an output coil, don't worry about it. So clearly we just have 3 protection inputs in the Hydroset schematic. Okay, that's the only thing we do have. The others are just normal input conditions. So we've done the inputs, so protection inputs. So now we can also look at the ordinary inputs. So these were assigned to memory bit 10 through 11. So let's see, insert input, or rather insert symbol. So we're going to have the raise Hydroset, lower Hydroset. Okay, so I'm going to say Hydroset HDR raise. Am I right in saying HDR? Hydroset pressure switch HDR. Or maybe I'll just do this. I'll just do Hydroset raise. Okay, and then insert symbol. Okay, we'll say Hydroset. We'll go like Hydroset lower. Okay, so I've done the raise Hydroset, lower Hydroset as ordinary inputs. Now we're not going to talk about the fault reset, because we already have a system fault reset in this symbolic table, so we won't even bother with that. So the other thing is the alarm cancel. Okay, this one here, this alarm cancel, which is an ordinary input. Okay, it's not a protection input, so it's ordinary. So insert symbol. So we're going to say Hydroset alarm cancel. Okay, so we've taken care of this one here, and then I think that pretty much takes care of the input. Okay, so now let's deal with the output coils and the indicator lamps. So for outputs, I think we're in the region of memory bit 103.2. So we come here, insert symbol. So in the first instance, we've got HDR. I know, I'm just getting everything so that we're able to relate the two schematics. Okay, we can even do away with this, but let's just get along with this. Okay, so that's HDR, memory bit 103.2. Insert symbol again. As an output, we've got 4CC1. Okay, so 4CC1. So this is what? This is Hydroset raise control. Okay, then we'll deal with 4CC2. Deal with 4CC2. Of course, clearly this is going to be the Hydroset lower control. Okay, Hydroset lower control. So insert symbol again. So we've done Hydroset raise control, Hydroset lower control, and then we've got 4CD1. Okay, 4CD1. This we can call what can we call you? What did we call the others? Let's see. For CD1. It's not the first time we're coming across this. PO. Okay. 282 maybe. Better control interlock. 281 main drive control. What was the other one? 283. Okay, what did we designate 283 as, so that we're using the same terminologies? So 283 was this one. We said main drive status faulted or healthy. Okay, so for CD1 we can just call Hydroset status. Okay, you can just say Hydroset status faulted or healthy. Okay, so which takes care of this one here. Okay, and then the indicator lamp, Hydroset faulted indicators, 283. So 283 was this one. There's 2H1. 2H1 was this one here. Okay, 4-trip indication. So main drive status faulted indication, so we're going to copy that, and then we want to apply it to 4CH1 as an output. Okay, so 4CH1, and then it's going to be Hydroset status faulted indication. Okay, because clearly the only way this indicator lamp comes on is if ngakuri fault, thermal overload, or earth leakage. That's when this lamp comes on. And then thereafter we're talking about 4CH2, and then come here. So 4CH2, and then this is going to be Hydroset on, because irrespective of the operation, whether mlefo kushita raise Hydroset or lower Hydroset, this lamp is going to be on. So that's why I'm just calling it as Hydroset on, this lamp here. And then of course the solenoid valve control. Okay, so this one is an output, so we need to come here. So this I can just call SVC. Okay, meaning solenoid valve control. So when you talk about solenoid valve control, I'm just referring to the control of the solenoid upine. We go on to the next run. So HDR we don't need to worry about, because HDR not to lembakale. Okay, so HDR is already there. The associated auxiliary contacts, we can just implement them in step 7, but the only thing we need is this lamp here. Okay, so this one is Hydroset pressure. Okay, so insert symbol. What's going on here? So Control Z. As an output I need to come here. Okay, so we're going to say HDR. Okay, so this is indication. Okay, indication like so, and then of course insert symbol HDR fault. Okay, so which is HDR okay is this lamp, which is controlled by way of a normally open indication in the normally open auxiliary contact of HDR, and then HDR fault is the one which is controlled by way of the normally closed auxiliary contact. Okay, so HDR fault, again this is just indication. That takes care of this takes care of that. And then lastly we've got the Hydroset low pressure siren, which is also an output. Okay, so insert symbol what are we going to call you? Hydroset low pressure styrene. Okay, so hydroset low pressure. So hydroset low pressure styrene, which takes care of this one here. Okay, so to save, because I believe we have all the inputs taken care of. Okay, so now that we have this done, we come to our function. Okay, and then when we do come to our function in the first run, clearly all we need is the hydroset pressure switch input. Now you have to realize that ion thermal protection inputs externally, we are wiring them through normally closed contacts. Okay, normally closed auxiliary contacts, and the way we dealt with the input validation gamuleyibukisha, every normally closed protection input which was wired into the system, for you to use it in a normal state, it needed to be used in the normally closed condition, if you remember what we did. And then of course we've got an output coil. So this one here, so a hydroset pressure switch, HDR. Okay, where hydroset pressure switch, which is this one here, and then it's controlling what we're designating as HDR. Okay, which is this one here, takes care of that. And then again, we could also go the way we were previously doing this, because if you remember, there's an aspect of protection. Okay, but the only thing here is the operation of the hydroset does not directly impact the operation of the system, apart from the pressure. Okay, the hydroset pressure, which is why maybe naidatwalela ndati NDR I feel this could easily be HDR. Okay, this can easily be HDR, even though tabailangila hapa, but because of the nature of this, that the hydroset pressure needs to attain a certain level. Okay, so meaning if the normal state of this is normally energized, if this is supposed to be normally energized, which we have determined, so that in the first control for the loop, okay, in the first control, because this schematic we have referred us back to had to do with the crusher lubrication control, but more importantly, the first rung, rung position 3, only had to do with the safety relay. So upper titwalanda ni HDR, and it's shown in the energized. This is shown as closed, but we can think of the auxiliary contact of the HDR control relay to abomfiako normally open, so that if the normal state is energized, this part will also be energized. Okay, so that takes care of this, right? Anyway, seeing as how there are not so many things in this circuit, we can choose to just have the equivalent logic in step 7. Okay, what I mean by this is I can choose to just insert a network. Okay, and then having done this, I need 4CE2, 4CE3, and no, we can't do this. We'll take this branch here. Okay, we'll take this branch, and then what we're going to say is we can choose as normally closed, then we can negate. Okay, negation, and then an output coil. Okay, and then of course, like we said previously, we need to seal in, like so. And then of course what we're going to do now is have these, okay. Then of course in this path, it doesn't really matter, we can even put the reset either in this position, okay, or we can put it in this position. So it can also be like this, or it can also be like in this position, okay. Same thing, okay. So this is what 4CE3. This is going to be 4CE3, and then 4CE2, then of course we've got the system fault reset, okay. For the system fault reset, and thereafter we've got 4CD1, okay. We've got 4CD1 like so, and then of course we need to seal in, okay. So we just get this and paste there, okay. So what else do we have? We've taken care of this, and then of course we've got the issue of the lamp, okay. So for the lamp, we can either choose to come here, put an output coil, and then say 4CH1, okay, and then we can do it like so, or we can just create another network, normally open contact associated with this output coil, get this output coil like so, delete that, same thing, okay, except I seem to like this one, it's more neat, okay. So all right, and then thereafter, what else? In as far as the protection is concerned, this takes care of everything, okay. Now the reason why I chose to go this route is because of what happens next, okay. Insert network. So this one here, auxiliary contact, in the normally closed condition, we'll put it there like so, and then thereafter it takes care of this part, okay. And then a parallel configuration or an O configuration, okay, is going to be such that we can choose to raise, okay. So hydroset raise like so, and then normally closed auxiliary contact of the opposite power contactor. So in this position, for raising, we're going to have 4CC2, okay, 4CC2, like in this position, 4CC2, and then with an output coil of 4CC1, okay, like that, takes care of this, right. And then we'll do the same thing for the other position, right. So we can do the same thing twice, or we can just create a parallel branch, normally open, with hydroset lower, okay. Hydroset lower, normally closed contact associated with 4CC1, like that, and then we get ourselves an output coil, designation 4CC2, okay, like that. So we've taken care of this branch, okay. So just to review, we've taken care of the first network in this schematic, which is rather rung 58, taken care of, and then we've taken care of rung 63 and 64. These two are taken care of, and then We've also taken care of the raising and lowering action. Okay, and then thereafter, the only thing we need to concern ourselves with is the Hydroset running. Okay, so this is essentially just an all configuration. So to allow Chitamo insert network, okay, now not this. So we need a normally open contact, parallel branch, then close with an output coil. Then with this we have 4cc1 like that, we have 4cc2 like that, ADO to quad 4ch2. Okay, to quad 4ch2, which is Hydroset on. Hii ni chaya rank 65. Then SVC, solenoid valve control, I think it also shares in this configuration upper, because these two are essentially the same thing, BDI. So what can we do? We can do this, create an output coil, and then we just say SVC. Okay, you can do it like this, but well, I'm not really into this. Okay, I'm not really into this. So alternatively, we could have chosen to see it like this. Could have chosen to see it like this. Could have chosen to see it like this. Okay, same thing. Okay, it's pretty much the same thing. It may look different, but it's essentially the same thing. So we've taken care of this, we've taken care of that, and then thereafter we're talking about HDR related operation. Okay, so we've already done HDR, which is this one right there. So we can even do a little bit of readjustment. Okay, I'm going to cut this. I know I'm not changing anything. I just want to have these file konkana so that we know what we are getting ourselves into. So insert network. As it relates to HDR, if HDR is energized, okay, when HDR is energized like so, we got an output coil. So we did say HDR, okay, as an indication. Okay, so insert network, or if you wanted, you could also create a parallel branch, negate, then an output coil, and then you can just say HDR fault indication. Is it? Okay. Yes, I think this is it. HDR okay, then HDR fault indication. So it's essentially the same thing here. Okay. So, but in the event that this is true, that the HDR, the Hydroset, is in a faulted state, we also want the Hydroset low pressure siren to be active. Okay, so we can also do the following. We can have this normally open contact associated with this one here, and then we need to have a normally closed contact associated with the Hydroset alarm console, HDR alarm console. Oh, come on. HDR. We're looking for that Hydroset alarm console. Hydroset alarm console. We're looking for this one here. and then the Hydroset alarm cancels as an output coil as Hydroset low pressure siren. Hydroset low pressure siren. Hydroset low pressure siren, which is this one here. Okay, so we've got our Hydroset low pressure siren active, so that all you need to do is actuate this. Okay, and then also we may need to remind ourselves, okay, because this is just a toggle switch, so I'll need it open and I'll need an additional output, okay, in the sense that now we're going to use the same address, Hydroset alarm cancel. We're going to use it in this position, and then we're going to define an additional output. Okay, so we're going to come to the outputs like there, insert symbol, and then Hydroset alarm cancel active. Okay, so Hydroset cancel active. Okay, like so. We've got our Hydroset alarm cancel active, which is going to be an output like that. And the reason I'm saying there's an Hydroset alarm cancel active, let's assume the Hydroset pressure dropped. Okay, so you go there on your system, then you toggle this alarm to this switch to cancel the alarm. Okay, and then everything is resolved, and then you forget to reset the alarm cancel, which is a problem because the next time this happens, the alarm won't come on. Okay, so we'll need for us to be one to say you have activated the Hydroset alarm cancel situation. Okay, so that's why I've added this. It wasn't in this, but we've made an adjustment. Okay, so I think pretty much this covers the operation of the Hydroset. Okay, this takes care of the Hydroset, and this is where we leave this for now. Okay, and then maybe before we forget what this is, we need to go back to where we started, to protection level 1. Okay, just so we add this, the situation that has to do with the Hydroset low pressure. Okay, so we will need this address here so that the whole system is now complete. We'll go back to protection level 1, I think, and in protection level 1, for the safety relay, we're going to insert a normally closed contact and then associated to that address we just created, like so, and then I think we're good to go. Okay, because initially we said we didn't know what NDR was, but I'm thinking it adding HDR, which is why I've added it. Save, yes. So this is where we end with the Hydroset control, and I hope it has been insightful as to why we do this. Now I do realize you may be conflicted against why I've chosen to use ama normally close contacts, but ngana munkonko kuda twafumine kuda twalela that input validation, we explained how we ended up using these internally in our logic as normally closed, even though externally they were wired through normally closed auxiliary contacts. But because of the way we were validating our inputs, this is how come we got to use them internally as normally closed conditions. Okay, so hapo tuwapelela ni hapa pene in as far as Hydroset control is concerned.